Alright, this is Unit 6, Lines and Triangles, and this is Day 4, Triangle Congruence by Side, 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 and Side, Angle, Side postulates. We're going to get to those postulates here in just a minute and actually working with some proofs, but for right now, let's just start simply. Geometric figures are congruent if they have the exact same shape and size. With that, we could actually name congruent parts of these two triangles. All told, there will be 6 pairs of congruent parts between those two triangles. I wasn't even given a diagram, but from this congruence statement, which is what this is a congruence statement, I would know that segment AB would have to correspond with segment LM, and if the two triangles are going to be congruent, that means those segments are congruent. I also have that segment BC would have to be congruent to segment MN. And that segment AC is congruent to segment LN. Now I could also name congruent angles, because not only do they have the same size, which these segments would be, they also have the same shape, which is what the angles will determine. That angle A is congruent to angle L, that angle B is congruent to angle M, and that angle C is congruent to angle N. Just as a quick note, sometimes when we see the figure, there might be multiple angles at point N. So sometimes we'll have to name these angles out. And if I was talking about angle N in this case, I'd have to call it maybe angle MNL. That would be angle N that I named a moment ago. Or angle LNM would be the same angle. So it just depends on the figure that we see, and you'll see me actually reference that throughout today's lesson. And one thing that you'll want to write down in your notes that actually gets used quite a bit in our proofs, and you'll see this later, is corresponding parts of congruent triangles are congruent. You will see me abbreviate this as CPCTC. Please make sure that if you're going to use that abbreviation that you remember the order of the letters. In my opinion, it's more important to really remember the words here. And in fact, one of the questions on my test actually at the very beginning will be, what does CPCTC stand for? And you'll have to write out the words. So you already know a test item at the end of this unit. Alright, we're going to find the values of x and y. Since the place where I see an x, there's also a y. I'm not going to start with x. I'm actually going to start by finding this y right here. When I do this, I'm going to use the congruent statement. I'm not going to try to guess what angle over here that matches up to. There's no sense in guessing. It tells you what angle it matches up to. So since 6y minus 14 is on angle O, I will refer to my congruent statement. Angle O corresponds to angle P, and angle P is 40 degrees. So now I know what to set 6y minus 14 equal to, 40 degrees. So I'm going to go ahead and get that set up. That's 6y minus 14 equaled 40 degrees, because corresponding parts of congruent triangles are congruent. Add the 14 over and divide by 6. Y equals 9. Now that I've got that, I will go and find x really quick. First of all, I'm really going to quick change this to x minus 18, and by dropping the 9 in for y. Now I'm going to refer to my congruent statement again. This is on segment NG. When I look up here, segment NG corresponds to segment IT, so it's going to equal 7.5. So x minus 18 equals 7.5. Again, not guessing on which side it is. I look at the congruence statement and it tells me what matches up. And I will add the 18 over and I will get 25.5 for x, and I'm done with this problem. I have found x and y. One of the things that we're going to be using also in this class is third angles theorem occasionally. It does crop up. What happens is when you have two triangles, if there are two pairs of angles that match up, then the third pair of angles, in this case angle A and angle L, also have to match. They will be congruent as well. And that's what this statement says right here. I'm not going to do a proof for this theorem. I will quickly explain that. You would start out by saying the measures of these three equal 180. The measures of these three equal 180. You would say then that the sum of the measures actually equal each other because they were both equal to 180. That was, by the way, using triangle angle sum theorem. Once you do that, then you can use substitution for angles B and C, turn them into angles J and K, and then subtract them from both sides. And you'll see that angle A is congruent to angle L. If you want more help with that, let me know at some point and I'll show you that proof in detail. All right, in today's class, we're going to have two different ways to show that triangles are congruent. One of them is the side, side, side postulate. And if you're in my class, you're going to see me do a construction, and I can show you that at some point if you like. But the side, side, side postulate states that if the three pairs of sides are congruent between two triangles, then the triangles are congruent. Not knowing anything about their angles, that these two triangles would be congruent, therefore their angles would actually be the same. That's enough information to show the triangles are congruent. So with a triangle, you don't have to show that every pair of segments and every pair of angles are congruent in order to show that they're congruent. There are shortcuts for triangles, and this is one of them, the side, side, side postulate. The other one that we're going to be using today is the side angle side postulate. And there will be a couple more to come. This list will grow. With the side angle side postulate, if you have two sides and the angle that's between the two sides, it can't be one of these other angles. See, that would turn it to the angle side side postulate. That would be SSS, and that spells a dirty word. You can't do that. Okay, but that doesn't work for another reason that I'll show you by a construction at some point. Here, these two triangles would be congruent because they have two pairs of sides congruent, and the angle that's between those two sides are congruent. So side angle side postulate, these triangles would be congruent. Then I would know that the third pair of sides would be congruent, and the other two pairs of angles would be congruent to their corresponding parts. So now a problem like example 2, the easiest way to show if these triangles are congruent or not is actually to use side, side, side postulate whenever we're given coordinates, because we can actually use distance formula to calculate their distances. So if they're going to be congruent the way it's described in the problem, then I know that, let me get that out of the way, I know that MN is going to need to equal QR, corresponding parts. I also know that NO is going to need to equal RS. And I also know that MO is going to need to equal QS. Now what I'm going to do is I'm going to use distance formula to actually test all of these and see if they all match up like they should. So let's go ahead and try it. For MN, it is equal to the square root of 0 minus -1 squared. And what I'm using here is distance formula. I'll write that at the top just in case you don't remember. If you don't, you need to memorize this. Distance formula, very helpful. You don't even have to graph things out. So, I just did MN, so 0 minus -1 squared plus -1 minus -4 squared. And I'm going to see what this comes out to. I'm going to simplify that down. So I have 1 squared plus 3 squared. So that's going to be the square root of 1 plus 9. That's the square root of 10, and that won't simplify. Now let me see if QR comes out to the same thing. And if it does, I'll continue on with this and see if the others are equal. If it does not, I'll actually stop and say that the triangles are in fact not congruent. So for QR, I'm going to do 3 minus 4 squared plus -3 minus -4 squared. So here, I'm going to get that QR is equal to the square root of -1 squared plus 1 squared. Oh, this is not looking like it's going to be. So I've got QR equal to the square root of 2. Because of 1 plus 1 is 2. These are not, in fact, equal. They do not match. I don't need to continue on with this. I don't need to test these other two. Since this first pair didn't work, they are not congruent, as is said in the congruent statement. Maybe the triangles are congruent, but the statement's different. That's fine. If they had matched, if this had been true, I would need to go on and test it out for NO compared to RS and MO compared to QS and see if all three pairs match. If they do, they would be congruent by the side-side-side postulate would be my answer. If you're sitting there thinking, hey, where's the proofs at? Here you go. All right, I've already written down the given. This is a triangle proof. And with triangle proofs like these, most of the time you're just going to try to show that your triangles are congruent. Sometimes that's going to be the end of the proof. Other times you're going to need to use that information to then show that particular parts are congruent. But in one way or another, try to show the triangles are congruent. So looking at these two triangles, they do end up being congruent, and that is by the side-side-side postulate. Now, I've only got two pairs of sides shown, but there is a third pair of sides when you consider the middle right here that's in common between both of them. That's a really common one to get to use, and that's called reflexive property, that segment LN is congruent to itself, segment LN. And again, that's by the reflexive property of congruence. There's a reflexive property of equality. This is the reflexive property of congruence. Okay, now that I've shown that, now I can show that these two triangles are in fact congruent. So statement number 3, that triangle, you can name the first one whatever you want to. I'll call it LMN. But now that I've named that first one, I need to be really careful about naming the second one to where the parts will actually match. LM corresponds to LP. So I'm going to call it LPN. That way all the corresponding parts match. So statement number 3. Why was I able to show that these two triangles were congruent? I used the side-side-side postulate. At that time, sometimes this is as far as you're wanting to go on these triangle proofs, where you just show the triangles are congruent, you'd totally be done. But in this particular case, it wants us to go a step further and show that angle M is congruent to angle P. And looking at my statements, those are corresponding angles. So these two angles up here would totally be congruent. I don't know why I'm talking like that, but anyways, angle M is congruent to angle P because corresponding parts of congruent triangles are congruent. CPCTC. Not enough to know just the letters. Remember, I am going to ask you, hey, what does this stand for? So you're going to have to be able to write that out. This wraps up that proof. These triangle proofs are usually pretty straightforward like that. All right, another proof as an example. What we've got here is two congruent triangles. They end up being congruent. That information wasn't given to us. We'll have to prove that. They do say that segment AE is congruent to segment CE. That was part of our given. Also, that segment DE is congruent to segment BE. You can see I marked that information on my diagram. Again, I'm going to show that these two triangles are congruent in order to be able to prove this at the end. From looking at the diagram, I'm not able to use reflexive property here. There's no segment or angle in common between the two triangles, but I am able to say the vertical angles that are present. That's angle AED is congruent to angle BEC. So for statement number 2, that's actually where I'm going to go with this. Angle AED is congruent to angle BEC. When you're stating angles, you're less particular because if I say angle BEC and I say angle CEB, I'm talking about the same angle. There's no difference between those names that I just said. However, whenever I'm talking about triangles, the order really, really does matter when you're making a congruent statement. By the way, these were congruent by the vertical angles theorem. All right, now that's actually enough information there to show the triangles are congruent because of, check it out, side, angle, side. The angle that's congruent is between the two sides that were congruent. So I'm going to call the first triangle maybe triangle AED. That triangle is congruent to triangle. You got to make sure that your parts match. If I call it BEC, that would be wrong. See, AE needs to match CE, so I'm going to call it CEB. Again, with triangles, that order is very particular. So, statement number 3, side angle side postulate. You are allowed to abbreviate those as I did on the last problem. Now, again, sometimes this is where you stop. You would have said side angle side and you would have been done if I were to be proving that the triangles are congruent. However, this proof wants to see that these particular segments are congruent. So now let's take a look at our statement. Does segment AD in fact match BC? Yes, they do. They are corresponding in our statement. So I know that that is true. That segment AD is congruent to segment BC. And this is because corresponding parts of congruent triangles are congruent. I would say maybe like half the time you wrap up with this as a statement with these triangle proofs. It's really common to wrap up here, but sometimes you're only trying to show the triangles are congruent. So just look at the problem and see where you're actually supposed to be finishing up here. All right, that wraps up the day. Hope you were able to understand everything. Please let me know if you got any questions.